Our next topic is called implicit differentiation. And implicit differentiation is used when you can't, it's used when to find the derivative when y is not explicitly defined in terms of x. So it's used to find the derivative. It's just a different technique. When y is not explicitly defined in terms of x, but it is differentiable. So what I'm talking about is something like, okay, well, I want to find the derivative of a circle. And what this technique involves is that every time that you're going to take the derivative of something containing y, you multiply by y prime or you multiply by dy dx. So let's take a look at some examples here. Let's take that circle example first. Let's say we have x squared plus y squared equals 9. You may remember this from last year from Algebra 2 with analysis. That's a circle, has a center at the origin, a radius of 3. And what I'm going to do if I take the derivative is I'm just going to use power rule. To take the derivative of x squared is just 2x. I did not take the derivative of y, so do not have to multiply by y prime. To take the derivative of y squared, it's going to be 2y, but I do multiply that by y prime, or sometimes you'll see books multiply it by dy dx, it's the same thing. And the reason I multiply by y prime is because that is what I'm going to solve for in just a moment. And I took the derivative containing y, so I multiply by y prime. And that would equal 0. Remember, the derivative of 9 is 0. Now I solve that for y prime, so you get y prime equals negative x over y. And if I wanted you to, like for instance, if I wanted to say, okay, let's say I wanted to find the slope of the line tangent to the graph, or let's say I wanted to find the equation of the line tangent to the graph. Let's do x equals 1. So at x equals 1, first of all, I have to use the original equation and find that it happens two places. Y could be plus or minus 2 square root of 2. It's plus or minus because you're going to take the square root of 8 and you have to consider both the positive square root of 8 and the negative square root of 8, which means there are two tangent lines, one on the left side of one on the top of the graph, top of the circle, and one on the bottom of the circle. And this one is 1 and then negative 2 square root of 2. And we have to use those points to plug in for x and for y to find the slope of the line tangent to the graph. So when I plug in into the first one in here, I get 1 on top and I get a 2 square root of 2 on the bottom. So that means the slope for this first one is going to be y minus 2 square root of 2 equals negative 1 over 2 square root of 2. And I don't care if you simplify that, near do the AP folks, times x minus 1. And then the other one is going to be the same as that, but it's just going to be the opposite sign because the negatives, this negative will cancel out with that negative. So it's going to be equals 1 over 2 square root of 2 times x minus 1. Sometimes it can be a little bit more complex finding the derivative, like you might have to do product rule, or you might have to, and you have to be careful about negatives and all that kind of stuff. And very common problem that you're going to see on the AP exam or on my exams are ones that ask you about horizontal and vertical tangent lines when it involves implicit differentiation. So if I have something, let's say I have hold on, there we go. Let's say I have 2x squared minus xy, and that term is the really hard term, plus y squared equals 12. And let's first of all say, okay, well, I just want to find the derivative. And find the derivative, I find the derivative of each piece individually. The xy term is going to be a problem. So the derivative of 2x squared is 4x. I'm going to put minus, now I'm going to do parentheses, because to take the derivative of xy, it's two different things, two different relationships, so I'm going to have to use product rule. So the derivative of x is just going to be 1 times y, but I don't multiply by y prime. I don't multiply by y prime, so it didn't take the derivative of y. Then it's going to be plus, because of product rule, the derivative of y is y prime times x, so it's xy prime. And that closes parentheses. And that I have in parentheses, that's always going to be the derivative of xy. Pull any constants out front, pull any negatives out front, that will really help you. And then plus 2y times y prime. And that again equals 0. Now to solve that for y prime, what I want to do is I want to gather my y prime terms over. I'm going to distribute this negative. I'm going to gather up the xy prime and the 2y y prime. So I'm going to get 2y times y prime minus xy prime equals y minus 4x. And then factor out a y prime they have in common and divide by what's left over. So y prime is y minus 4x over 2y. That's a y. 2y minus x. And what that's going to tell me is that's the derivative. That's just simply the derivative. So now, from that point forward, what I can do is I can ask you some extended questions, like where do I have a horizontal tangent line? Horizontal tangent line are going to occur where the derivative is going to be 0. In this particular case, it's going to be where the numerator is 0. If I ask you about a vertical tangent line, it's going to be where the denominator is 0, where the derivative is not defined. So let's do that. So if I asked you about a vertical tangent line, that's going to occur when 2y minus x equals 0. If I solve that, x equals 2y. Okay, all good. Now, how am I going to get where that occurs? Actual numbers. Okay, I get that by plugging it back into the original equation. So I'm going to use some substitution. So instead of writing x, I'm going to write 2y. So I'm going to rewrite the original equation as 2 times 2y quantity squared minus 2y times y plus y squared equals 12. That's a lot of y squared, so I get 7y squared equals 12. Or y equals, in my particular case, it's going to be plus or minus the square root of 12 over the square root of 7, or the square root of 12 sevenths. And then once you have that, to get x, take that and put it right back here. So x would be plus or minus 2 square root of 12 sevenths. Not nice numbers, but that's just not nice numbers because of the algebra, not because of the calculus being so bad. So you can expect to see things like this. You can expect to see horizontal tangent lines. You can expect to see vertical tangent lines. But the big concept today is implicit differentiation. And how do you deal with implicit differentiation? And we can combine that with our other rules like chain rule and product rule and all that stuff, as I did in the couple of examples.